Here we go with take 8 on measuring light on an object. The problem that I had with developing an inquiry for my students was that the limited time that I had to come up with this project, I went through all of the websites that we had for the class, and I couldn't find one that would be able to be fully developed within the time constraints that I had. So what I decided to do was to focus my attention on my 3rd through 5th grade G&T students and use level 2 inquiry. I asked them if they wouldn't mind giving up one of their class periods so I could devote 2 class periods to this inquiry. And they said that they wouldn't mind doing that. So the question that I posed to my students using inquiry: develop a tool or a process to determine how light influences temperature of an object. When the students came in, I handed them the temperature sensor tag, or excuse me, the Texas Instrument sensor tag, and I let them know how it worked and let them play with it for a few minutes. And then I gave them the question of how does light influence temperature of an object. I told them that they could use any of the supplies in the classroom, and I wanted them to create a device or a process that would answer the question that I just posed to them. I asked them to use the first class period to develop their research and blueprinting, and the second class period to be used for the testing of whatever it is that they came up with. Some of the questions that I asked them to focus on was what is light intensity, explain radiated heat, explain absorption, and are wavelength and temperature related. So the students were able to develop a blueprint after they did the research of light intensity, radiated heat absorption, and seeing wavelength and temperature and how they're related. And they decided that they were going to use color absorption and heat using the sun and flashlights. So they were able to find some flashlights in my classroom, and they decided that they were also going to go outside and enjoy the beautiful sunshine. They went and gathered paper from our construction bin, and they found the thermometers that I had placed, and also the sensor tag. They did some preliminary work just to decide what they were going to use. They also found some blacklight flashlights and determined they were not going to be able to be used. And then they gathered all the materials and they were ready to go. First stop was going outside. They were going to test light absorption with the sun. So they lined up all of the paper that they were going to use for testing and put thermometers on top of them with weights so that the paper wouldn't blow away. And then they waited 5 minutes. After the 5 minutes were up, they had someone keep track of what the temperatures were going to be. Somebody else was in charge of the light sensor to make sure that the light wasn't changing too much over the course of the 5 minutes. They recorded their results, and then they looked at the results and scratched their heads because it did not match their hypothesis, which their hypothesis was that the darker pieces of construction paper would have the greater amount of temperature. So they decided to test the results again, which they did. They waited another 5 minutes. They moved the papers around a little bit more. They made sure that they stayed away from the papers so there wouldn't be any shadowing. And the results changed a little bit. The brown paper actually this time had the greatest amount of temperature, and then some of the papers in the middle had the greater amount after that. So the results were a little bit skewed. So with that, they decided that they needed to test some of the equipment that they were testing. So they said, let's look at the thermometers. Maybe there's something wrong with the thermometers. So that they laid them all out on a piece of paper, tested them for 5 minutes, and it came back that all the thermometers were reading the same temperature. So they realized that that wasn't a problem. So some of the other things that came back with their testing of equipment was maybe their paper was too small, or maybe they shouldn't be testing things on blacktop, or maybe the shadowing was an issue. After they realized they were running out of time, they all raced inside, grabbed their second testing module, which was going to be the absorption with a flashlight. They had their light sensor ready to go. They had their flashlights on, and they began testing the process. One person realized that there wasn't much going on with the light sensor, and after the 5 minutes, they also realized that there wasn't much change with the heat that was radiating from the paper. So there was conclusions that needed to be drawn. So I asked them to come up with a conclusion based off their hypothesis. And from that, the students said that there was no way they were going to come up with a conclusion because they felt that they needed more time. If we had more time, we would have changed some stuff to make our test better. The test outside was on a windy day, and that affected our test. I think if we could have had larger paper, it would have been better. And then finally, one of my students said, I'm not done. Please let us come back. Can we try it again? My thoughts. I chose this type of project because I love to immerse my students into active learning. I chose to include scientific questioning because it's lacking in the area. All of my students were actively engaged in the process, and I enjoyed using they enjoyed using a new piece of equipment. While their inquiry failed to meet their hypothesis, the engagement that was seen was far better than the results. And by them saying that they wanted to keep going shows me that I was on the right track. And thank you for watching, and I enjoy doing this.